for this problem, we want to evaluate the limit as h goes to 0 of the square root of 4 plus h minus 2 all over h. Now notice, if I were to plug in 0 in here for these h's, I would get 0 over 0, which is indeterminate and can't possibly be the solution to this limit. So I need to go back and think about what is in my algebra tool bag. What tools do I have to simplify this expression? Well, what I notice is that there's a square root in that numerator, and I'm immediately thinking conjugate. So I'm going to multiply the top and the bottom by the conjugate of that numerator. The conjugate just changes this minus sign right here to a plus sign. Now I have to do the same on the top and the bottom so that I'm multiplying by 1 and not actually changing the value of the limit. So here we have that this is equal to the limit as h goes to 0. Now the reason that we multiply by the conjugate is now in the numerator there I have a difference of squares. So I know that that multiplies out to the first one squared minus the second one squared, all over, and now in the denominator, I am not going to multiply that out, because ultimately, I want to be able to do some cancellations, so I want to leave the denominator factored. Let's simplify that numerator. And the fantastic thing about having a square root squared is that square root goes away. So that's what multiplying by the conjugate did for us. And then minus 2 squared, which is a 4, all over h times the square root of 4 plus h plus 2. Now in my numerator, I have a plus 4 and a minus 4, so they cancel. So I'm left with the limit as h goes to 0 of h over h times the square root of 4 plus h plus 2. And now look at that. The denominator has an h, the numerator has an h, and they can cancel. So here, now, we have that this is equal to the limit as h goes to 0 of 1 over the square root of 4 plus h plus 2. Now, what happens if I were to plug 0 in for that h? Well, I get 1 over the square root of 4 plus 2, or 1/4. No more zeros in the denominator. So I was able to plug 0 in for h. And ultimately get my final answer.